Hello friends, welcome to Lahari Lectures. In this video, you can watch notes on graph traversal. To solve many problems modeled with graphs, we need to visit all vertices and edges in a systematic fashion called graph traversal. Traversal of a graph is completely used to search a vertex or an edge through the graph. Hence, it is also called a search technique. There are two types of traversal. First one DFS, depth first search. Second one BFS, breadth first search. First one DFS, depth first search, or stack or LIFO or pre-order. DFS traversal of a graph produces spanning as a final result is a graph without loops. We use stacked data structure with maximum size of total number of vertices in the graph to implement DFS traversal of a graph. Algorithm. Step 1. Define a stack of size total number of vertices in graph. Step 2. Select any vertex as starting point for traversal. Visit the vertex and push it onto the stack. Step 3. Visit any one of the adjacent vertex of the vertex which is at the top of the stack, which is not visited, and push it onto the stack. Step 4. Repeat step 3 until there are no new vertex to be visited from the vertex on top of the stack. Step 5. When there is no new vertex to be visited, then use backtracking and pop one vertex from the stack. Step 6. Repeat step 3, 4, 5 until stack becomes empty. Step 7. When stack becomes empty, then produce final spanning tree by removing unused edges from the graph. Example. Consider the following example graph to perform DFS. Step 1. Select A as starting point. Visit A. Push A onto stack. Below there is a stack. Push A onto the stack. Step 2. Visit any adjacent A which is not visited B. Push B onto stack. Step 3. Visit adjacent B which is not visited C. Push C onto the stack. Step 4. Visit adjacent C which is not visited E. Push E onto the stack. Step 5. Visit adjacent E which is not visited D. Push D onto the stack. Step 6. There is no new vertex to be visited from D, so use backtrack. Pop D from the stack. Step 7. Visit any adjacent E which is not visited F. Push F onto stack. Step 8. Visit adjacent F which is not visited G. Push G onto the stack. Step 9. There is no new vertex to be visited from G, so use backtrack. Pop G from stack. Step 10. There is no new vertex to be visited from F, so use backtrack and pop F from stack. Step 11. There is no new vertex to be visited from E, so use backtrack. Pop E from the stack. Step 12. There is no new vertex to be visited from C, so use backtrack. Pop C from the stack. Step 13. There is no new vertex to be visited from B, so use backtrack. Pop B from the stack. Step 14. There is no new vertex to be visited from A, so use backtrack. Pop A from the stack. Stack became empty, so stop DFS traversal. Final result of DFS is spanning tree. Below we can see the final result of DFS. Second one, BFS, breadth first search, or Q or FIFO. It is very different approach for traversing the graph nodes. The aim of BFS is to traverse the graph as close as possible to the root node. The BFS produces a spanning tree as a final result of graph without loops. We use Q data structure with maximum size total number of vertices in the graph to implement BFS of a graph. Algorithm. Step 1. Define a Q of size total number of vertices in the graph. Step 2. Select any vertex as starting point for traversal. Visit that vertex and insert it into the Q FIFO. Step 3. Visit all the adjacent vertices of the vertex which is at front of the queue, which is not visited, and insert them into the queue. Step 4. When there is no new vertex to be visited from the vertex at front of the queue, then delete that vertex from the queue. Step 5. Repeat step 3 and 4 until queue becomes empty. Step 6. When queue becomes empty, then produce final spanning tree by removing unused edges from the graph. Example. Consider the following example graph to perform BFS breadth first search. Step 1. Select vertex A as starting point. Insert A into the queue. Step 2. Visit all adjacent A which are not visited D, E, B. Insert newly visited vertex into queue and delete A from queue. Whenever you are inserting adjacent vertex, delete that vertex, that is A. Step 3. Visit all adjacent D which are not visited. There is no vertex. Delete D from queue. Step 4. Visit all adjacent E which are not visited CF. Insert newly visited vertices into the queue and delete E from the queue. Step 5. Visit all adjacent B which are not visited. There is no vertex. Delete B from the queue. Step 6. Visit all adjacent C which are not visited G. Insert into queue and delete C. Step 7. Visit all adjacent F which are not visited. There is no vertex. Delete F from queue. Step 8. Visit all adjacent G which are not visited. There is no vertex. Delete G from queue. Queue became empty. So stop BFS process. Final result of BFS spanning tree by removing unused edges. Thanks for watching. Please like, share and subscribe my channel. Thank you.